about what is called a Pareto chart. This is basically the same thing, but sorry about that. I kept my phone on, so I'm not going to answer. Oh, hello? No, it's not an urgent message. So the reason why I didn't put them here because of my handwriting. And what is a Pareto chart is basically the same thing, but arrange them in descending order, or maybe in ascending order. So this will be the first, 5 will be the next, 4 will be the next, 2, 2, 2, and 1, 1, 1. That's what the Pareto chart is. Some say that that is a better understanding because it also arranges them in descending order. So let's just do just that. I keep my phone on just in case a student cannot get in or something. Otherwise, I would not. Okay, so then in our case, let's just do the frequency. So Pareto chart, it's a bar graph. So let's put it in. What is a Pareto chart? It's a bar graph in ascending or descending order. In ascending or descending order. Okay, we normally prefer descending, in descending order. I'm not going to put all the categories because it will take me a while, but I'm just going to represent the 12. I'm going to represent the 5. That's in the next in line. That's the 4. Then we have 3 2s and 2 1s. Oops, here. So that's 1 1 1, 2 2 2, 1 1 1. So that would be a Pareto chart because why do we use it? It's because it shows what is happening here. So they're also organized in descending order. Okay, moving on. Any questions for me? This time we want to compare. We want to compare 2 data sets side by side. When we want to compare 2 data sets side by side, we prefer the bar charts. So compare 2 data sets side by side. Prefer, because that's what it works, the bar chart. The bar chart is a good representation of a comparison, or it will help us compare 2 data sets side by side. And let's see how. So here's an example for us. We have the frequency data represent the educational attainment, the level of education in 1990, and 2012, the second column, of adults 25 years and older who are U.S. residents. The data are in thousands. So in other words, 39,344 represents actually 39,344. Good to know. And we have categories. 1, 2, 3, 4, 5, 6 different categories in this data. So this is example 5. We have 6 categories. The first thing I'm going to do with the graphing calculator, I'm going to enter the information I have, the 39, 344, 47, 643, etc., all these in list L1, and then I will create the frequency, the relative frequency in list L2, and then this will be list L3, and then list L4 will create the frequency, relative frequency for the data from 2012. So let's start. Go back to stat, Go back to edit. Let me know if you fell behind or you need any help. Clear the lists that you had before. Clear the list L2. And let's type in list L1. 39344. Enter. 47643. Enter. 29780. 9792. 20833 and 11478. And we have the total. I should check my total again just to make sure that I'm not making an error. I know I'm not testing you whether you are paying attention or not. No. I just want to make sure that I don't have any errors in here. 20833. Check my mistakes, please, or my numbers. I did get 158870. That's okay. I'm checking the other one. 25276 plus 62113 plus 34163 plus 19737 plus 40561 and 22730. Yes, perfect. So back to our list. So I go to list L2. At the very top, highlight list L2. Copy list of L1 with second and 1. And we divide this by which number? Can anyone tell us which number we divide by to get the relative frequency? Exactly, 158870. Thank you very much. 158870. And press enter. We got relative frequency. We can insert it if you would like in a minute. So let's go back to list L2, 25276, 62113, 34163, 19737, 40561, and 22730. I hope I entered them correctly. Now once I make an error, I don't trust myself anymore, that day at least. Okay, so now in list L4, highlight the top of the list. Careful now because we have to put list L3. So list L3 goes with 3. So second key, list L3, and divide by the total. We have it right here, 204580. And press enter. And we got the relative frequencies for 2012. Now we want to draw side by side a relative frequency. We have 6 categories. I'm not gonna label them and just say 1, 2, 3, so I don't have to write all this. I'm gonna call this 1, I'm gonna call this 2, 3, category 3, category 4, category 5, and category 6. It's easier for me than writing it. So 1, 2, 3, 4, 5, 6. Since they are side by side, I'm going to use 2 different colors. So this will be the one, let me use maybe red or brown or purple, something else. So what you see in purple will be 2012. So purple, 2012, and blue, 1990. Yeah, 1990. Okay, very good. So this is the relative frequency. Back to our table. So the first category, let's take a look and see how high do they go. From 0.07 to 0.29, that's the highest. 30% is the highest. Let's say the last one. 30% roughly is the highest as well. So I'm going to use 10% or 0.1, 0.2, 0.3, 0.4, and let's go to 0.5. That's the relative frequency. So now in blue. In blue I have the first one, roughly 25. I'm also going to put the top what it is. So 24.76. The next in blue is 29. So I'm going to write in percentage, easier for me. Okay, the next one is 0.18 or roughly 19. All have the same width. So this is 0.1, oops, I have to keep 18.74. The next one is 0.06. So 0.06, it's not doing that. So 0.06, so this is 0.5, 0.06 is a little bit higher. So this would be 6.16%. Category 5 is 13, so somewhere here, I'm going to say 13.11%, and the last one is 0.07, more than 0.06, so somewhere here, so it's 7.22. We finished with 1990. Now we want purple for 2012. So the first one is 12%. The next one is 30%. Maybe I should just shade them in so you see the difference. Maybe the color is not very good, the difference in color, so I'm going to shade them like that. The next one is 16%, and maybe I should write 12.36. This is 30.36. The next one is 16.7. The next one is 9%. 9.65. And 0.19, so 19%. 19.83. And finally 11%. 11.11. Okay. So this is for comparing data. Comparing two data sets. Of course, we can compare more than just two data sets. We can compare more, but for now we have two by comparison. So what would you say? So it appears that over the span of 22 years, from 1990 till 2012, what happened here? 25-year-olds and older not having a high school graduate degree, not having to graduate from didn't graduate from high school. Did it increase over the span of 22 years, or did it decrease? Because we have the categories side by side, we can tell immediately that it had decreased by 12%. So 25-year-olds today are striving for better than just high school, or not finishing high school, not a high school graduate. What happens with the second category, the high school diploma? So in 2012, it increased. Not a lot, but it increased. What about some college but no degree? That went down by roughly 2%. What about associate degree? It went up by 3% in the last 22 years. What about bachelor's degree? Nicely done. By 6%, it went up. And what about grad or professional degree? It went up by 4%. Why do we need to do this in order to compare? It's because the totals are different. We can compare. We have to compare percentages. Percentages of this over this, this over this, etc. Like we did side by side. I think that this is quite a neat presentation of two data sets side by side in which we can draw different conclusions. What do you think? Anyone?
I think it's really helpful, at least for me, because I can see the differences in the data.
Right, and we can draw conclusions. We can talk about it. So that's the whole purpose of summarizing the data. So we can see what it tells us. If we don't summarize it, if we don't organize it, we will not be able to draw any conclusions. Very good. Any questions?